Okay, y'all, number 5 and 6 are tricky, but they're designed to help you learn to slow your brain down, look at each term individually, and ask yourself, where's the input being sent in that term? Because that'll tell you which derivative rule you need to use to take the derivative of that specific term. And each term can follow a different derivative rule. Or maybe they all follow the same derivative rule. It just depends on where the input is being sent. So pause this video, try 5 and 6 on your own. When you're ready, unpause and we'll see how you did. Okay, let's see how you did. So let's look at number 5. There is a lot going on. There are 4 individual terms, and we need to figure out which rules to use to derive each of the terms. Okay, so I'm going to rewrite this y equals notation as f of x notation, just to emphasize input. And let's think about this first term. My input is an x. Where's the input being sent in this first term? Nowhere. There's not an x in this first term. That means this first term is constant. And we know the derivative of a constant is 0. So boom, the derivative of e to the third is 0. E to the third is just some decimal number. You can find that on your calculator. You have an e button, you have an exponent button, you have a 3 button. Just some decimal. It's constant. It's not pretty, but it's constant. So the derivative is 0. Derivatives are rates of change. Constants don't change. The derivative is 0. Okay, now let's look at this next term. Think about the input. Where is the input being sent? To the exponent. That makes this term exponential. So we are going to follow our exponential rule. And I have the generic exponential rule up here because I know it's new. We're still learning it. So I'm going to follow that rule. Okay, so what does this rule say? It says we rewrite whatever the exponential expression was. So my exponential expression was 3 to the x. So I'm going to rewrite 3 to the x. And then I tack on the natural log of the base. In this problem, my base is a 3. So I'm going to do the natural log of 3. And then I do my chain rule. The input got sent to the exponent, so I'm going to tack on the derivative of the exponent. But my exponent is a plane x, and we know the derivative of a plane x is 1. So I really have 0 minus 3 to the x power times natural log of 3 times 1. Okay, now let's look at the next term. The next term is x cubed. X cubed. Where is that input being sent? To the base. I have a variable base and a constant exponent. That makes this a power function. Power function. So we're going to use our power rule. So you're probably pretty used to that one, right? So I'm adding that term. I'm going to drop the exponent down to the front, so that'll give me a 3. I rewrite my base x. I decrease the exponent by 1, so the exponent's now 2. And I tack on the derivative of the base. The input's being sent to the base, so the chain rule tacks on derivative of the base. But I know the derivative of x, again, plain old x is just 1. So I'm really adding 3x squared times 1. Okay, now let's look at the last term. Where is the input x being sent? That's right, nowhere. It is a constant. And the derivative of a constant is just going to be 0. Okay, so we're going to add 0 in my derivative. So now we can clean this up even further because multiplying by 1 doesn't really do anything. And adding or subtracting zeros don't really do anything. So my derivative is really just going to be a negative 3 to the x ln of 3 plus 3x squared. That's my derivative. Did you get it right? If not, that's okay. just ask yourself, okay, now that I've seen it worked out, do I really understand where all these numbers came from? And if the answer is yes, that's awesome. And if the answer is no, then you're like, whoa, okay, I need to go watch this again. Or I need to go reach out for help from a tutor. Okay, let's try 6. And again, if you haven't tried 6 yet, pause this video, try 6, and then we'll see how you did. Okay, let's see how you did. I've rewritten the generic rules for exponential and log functions here for us to reference. Okay, let's take the derivative, y'all. Okay, so let's find the derivative of each term in this function. So all comes down to the input. Where's the input being sent in the first term? To the exponent. That makes it exponential, so I'm going to follow this generic exponential rule. So the generic exponential rule says we start by just rewriting the exponential expression. So I'm going to rewrite to e to the x. Okay, then I tack on the natural log of the base. Well, in this case, the base is e, so I'm going to have the natural log of e, but that's just 1. And then my chain rule comes into play. The input is being sent to the exponent, so I'm going to tack on the derivative of the exponent. The exponent is a plain old x, and we know that the derivative of a plain variable is just 1. Okay, so I really have 2 e to the x times 1 times 1. ln of e is 1. The derivative of the exponent is 1. I don't really need those 1s. So the derivative of the first term is just 2e to the x. Okay, so now we're starting fresh. Let's look at the second term. Where is the input being sent in the second term? It's being sent to the base. I have a variable base. That means I'm going to use my power rule. As weird as this is, I have a variable base with a constant exponent. Let me zoom in a little bit there. So variable base x, constant exponent e. My power rule says I drop the exponent down to the front and multiply with the coefficient. So I'm going to have 7 times e. I'm subtracting that term, so I'm really going to be subtracting 7 times e. I rewrite my base, which is a plain x. I decrease that exponent by 1. So it's just going to be e minus 1. And then I tack on the derivative of the base. So the input was being sent to the base, so the chain rule tacks on the derivative of the base, which again is just a plain x. And we know that the derivative of a plain x is 1. So when I clean this up, I mean, there's not too much to do, but technically I'm going to subtract 7ex to the e minus 1 times 1, so I don't really need to write that times 1. Okay, so that term was tricky. That was power rule. Now let's go to the next term, the third term. Where is the input being sent in this third term? That's right, nowhere, because that is a constant. And we know the derivative of a constant is 0, so I'm really adding 0. So adding 0, we don't really need to write that, so I'm not going to include that in my derivative. And what's happening here in the next term? Where is the input being sent in ln of e squared? ln of e squared. Nowhere. There is no x in there. Again, this is a constant. There is no variable x. E's not a variable. E's a constant. Natural log e squared constant. Derivative of a constant is 0. So I don't need to include that in my simplified derivative. But we do have one more term, so let's look at this last one. Okay, where is the input being sent in the term 2 ln of x? Well, it's being sent to the argument. So now I'm going to use my log rule. I'm going to use the generic log rule. I could use the special case, but I'm going to do the generic. So what does this generic log rule say? Okay, so the 2's along for the right, so I'm going to write the +2, and I'm going to use the log rule here. Okay, So I have to know that natural log is the same as log log base e. So natural log of x is the same as log base e of x. And I need to know that because when I look at my rule, the very first step in my rule is to do 1 over natural log of the base. And I have base e in this example. So I'm going to do 1 over natural log of the base e. But the natural log of e is just 1. And then the next step of the rule says you do 1 over the argument. Well, my argument's just a plain x. So I'm going to do 1 over x. And then the chain rule component says I'm going to tack on the derivative of the argument. If the input got sent to the argument, I tack on the derivative of the argument. Again, my argument is just a plain x, and the derivative of a plain x is just going to be 1. So when I go to clean this up, I really have 2 times 1 over x times 1. I don't need those times 1s. So I really just have 2 times 1 over x. Well, I can write that, but technically this 2 is over a 1. So if I multiply numerators times numerators, I'll get a 2. And multiply denominator times denominator, I'll get over an x. So I can just simplify that as 2 over x. So this is my derivative. Again, if you got that right, awesome. High five yourself. If not, be honest with yourself. Do you understand where these numbers came from? If not, rewatch this part of the video. If that doesn't help, reach out to a tutor or to another human. Okay. Keep on keeping on, guys. It'll start to make sense. It'll start to click. You just got to practice.